In this video, we're exploring the measurements of data capacity. We already understand that everything stored in a computer system is stored in binary, those zeros and ones that represent just two states. For example, capacitors that store a charge or don't store a charge in RAM to represent a 1 or a 0. Magnetic north and south poles in hard drives, pits and lands on Blu-ray discs, current or no current with logic gates. This is because it's much easier and therefore cheaper to manufacture electronic component units with just these two states. However, this means that everything, literally everything, must be stored with only zeros and ones, known as a bit or a binary digit. It is clear that Boolean values, true and false, or on and off, can be stored with just one bit. However, to store more complex types of data, we need to use a combination of bits. For example, a single-digit LCD display requires 4 bits of data. I will explore how and why that is the case in a later video about binary numbers. Those 4 bits are called a nibble because they're half a byte. And yes, this is because computer scientists somehow think they have a sense of humour. Therefore, a byte is 8 bits. Those 8 bits can be used to represent lots of different types of data. For example, it could be a number. It could also be a letter or a symbol if every letter had its own binary sequence. Equally, it could be part of a picture or a sound file. This is exactly how computers work, and we'll explore each of these concepts in more detail in other videos in this unit. A single byte, whilst useful for storing a single character, is not enough for other types of data, and therefore computers started using thousands of bytes of data called kilobytes. As the binary system is a base 2 number system, these larger units are 2 to the power 10 units. 2 to the power 10 is 1024, so a kilobyte is actually 1024 bytes and not 1000. Now this doesn't make much a huge amount of sense when you're taught in maths and science that a kilo is 1000. Therefore we tend to approximate a kilobyte to 1000 bytes just for simplicity. Even 1000 bytes is not enough capacity to store most files, therefore we have a need for higher units of measurement. Here are the units of measurements you need to know for the GCSE exams. You will notice that the binary values of these units calculated by powers of 1024. Therefore, a megabyte is 1024 multiplied by 1024 bytes. Or expressed another way, 1024 to the power 2, which is 1,048,576 bytes. We're also able to express these as decimal values, calculated by powers of 10. For example, a megabyte is 10 to the power 6, or 1 million bytes. It is fine for GCSE to be using these decimal approximations. In actual fact, hard disk suppliers today have started using these values because it makes more sense to consumers. So today it's possible to have a hard drive of 500 gigabyte and actually have 500 billion bytes on the drive. So you see that 1024 or 1000 is a kilobyte. 1024 or 1000 kilobytes is a megabyte. 1024 or 1000 megabytes is a gigabyte. 1024 or 1000 gigabytes is a terabyte, and 1024 or 1000 terabytes is a petabyte. Now, in order to explain the background to all this, this video has become a little more complex than it really needs to be for your exams. For the purpose of exams, it's probably easier to remember the sequence: kilo, mega, giga, tera, peta. If you know that a kilo is 1000, 3 zeros, just add 3 zeros each time to the unit. Therefore a mega is 6 zeros, a giga is 9, a tera is 12, and a peta is 15 zeros. Often in exams you have to convert from one unit to another. For example, a 500 gigabyte SSD is 0.5 or half a terabyte. It is also 500,000 megabytes. To convert between the units, it's handy to remember you either multiply or divide by 1,000. Remember that a byte is 8 bits. So if you need an answer in bits, you need to multiply by 8. Here is this concept in action. Okay, so let's look at some real examples. Here we can see a list of files in a typical file storage system. We've hidden the file name so we can focus on what's important. If we take the top one, we have a Microsoft Word document, which is 1,470 kilobytes. If we wanted to know what that was in megabytes, then we're going to divide by 1,000. So that's 1.47 megabytes. Further down here, we have a Microsoft PowerPoint file, which is 740 kilobytes. Again, if we divide by 1,000, that is 0.74 megabytes. So it's quite straightforward to convert between the two units here. Typically, once we go above 1,000, we want to represent the data in the higher unit. In a similar way, here we have an Excel document which is just 25 kilobytes. If we want to know how many bytes that is, then it's 25,000 bytes. That's because a kilo is 1,000. If we want to know what it is in bits, then we take our 25,000 and multiply it by 8, as there's 8 bits in a byte. What comes next is technically a little beyond what you need to know for the GCSE exam, so there's no need to take notes on the rest of this video. It's worth watching, however, as it helps to clear up some common misconceptions. So our final observation is the symbol for each of these units: KB, MB, GB, TB and PB. And these are shown in capital letters because they're representing bytes, not bits. Confusingly, the capacity of drives and the size of files is measured in bytes using capital letters, but the data transfer speeds over network are measured in bits per second using a lowercase second letter. Therefore, one capital MB is not the same as one capital M small b. It's 8 times bigger.